This is a continuation of the Chapter 8 review, starting with problem 7. And the problem says, a cellular telephone tower casts a shadow that is 72 feet long, while a nearby tree that is 27 feet tall casts a shadow that is 6 feet long. How tall is the tower? Now, I'm very visual, so I like to draw pictures. So here is a tower, and it casts a shadow that's 72 feet long, and we don't know the height of that tower. And we have a tree which is 27 feet long that casts a shadow 6 feet long. So let's set up a proportion with this. So we know that x is to 72 as the height of this one, 27, is to 6. So I just said height is to shadow as height is to shadow. I could have said height to height, shadow to shadow. It really doesn't matter. These proportions would work out the same either way. So now I just have to multiply both sides by 72. X equals 27 times 72 divided by 6. We put that in our calculator and get 324 feet. And now let's move on to the next problem. In these two problems, we are to use the side-side-side similarity theorem or the side-angle-side similarity theorem to show that the triangles are similar. So for number 8, we're going to use side-angle-side because we have two sides and an included angle. So what we need to do is we need to find the ratio of these corresponding side lengths, and they need to be proportional. So first we have 4 is to, so this side is to the entire side length. Be very careful because we're not dealing with 4 to 8. We're dealing with 4 to 12. So the side of this little triangle and this corresponding side of the big triangle. So 4 to 12 gives us 1/3. Then this side, which is 3.5, is to 7 plus 3.5, which is 10.5. And this also simplifies to 1/3. So we verified that these corresponding sides have the same ratio. We know that angle C is congruent to itself by the reflexive property. So these two triangles are similar by side-angle-side similarity. Now for problem 9, we have sides, side, side. So it looks like we're going to be using side, side, side in this one. So let's start out with UR. That's the easiest one to figure. So 10 to 15 is 2/3. Then let's take QU, 9 to 9 plus 4.5. Again, we're dealing with this side of the triangle and the entire side, TQ. So it's TQ and QU. So that's 9 plus 4.5, which is 13.5. Unfortunately, that also comes out to 2/3. And then we have 14 is to 14 plus 7, 21. And you can see that this is also 2/3. So therefore, these two triangles are similar by side, side, side similarity, not to be confused with side, side, side congruence. Let's move on to the next problem. This problem tells us to find the value of x that makes triangle ABC similar to triangle DEF. In order for that to be true, all these sides have to be in the same ratio. Now we have two expressions in terms of x. So I want to be careful here because I don't want to create a nightmare for myself. I don't want to have some really nasty quadratic to solve. So let's be intelligent here about the choice of sides we're going to use to find the value of x. This is the simplest expression for x, so I'm thinking I'd like to use that. BC corresponds to EF. So that's good. So let's write down the beginning of our proportion. We have 2x is to, so BC is to EF, 32. Now I'd like to pick ED, because I don't want to have this guy so that I have to multiply these two together. So ED is 24. ED corresponds to AB, and oh happy day, AB is a number, 6. So I know then that 6, because I started with triangle ABC and I end with triangle ABC, 6 is to 24. Now it's a relatively simple process. 2x equals 6 times 32 divided by 24, and that gives us 2x equals 8. Therefore x equals 4. Now to check, let's put that in here. 6 times 4 plus 12 is 36, and 2 plus 4 is 8. So this is BC. So I know that, let's just write these ratios. So AB to DE. AB is 6. AB is 6. DE is 24. And then BC is 8, which is 2x is 8. BC corresponds to EF. EF is 32. And AC, 9. AC corresponds to DF. And DF we just saw was 36. Now let's figure out what these are. So 6 over 24 is 1 over 4. 8 over 32 is 1 over 4. And 9 over 36, 1 over 4. So that value of x works. We verified with all three sides of both triangles. And now let's move on to the next problem. In these problems, we're asked to determine whether segment AB is parallel to CD. This is going to be using a variant of the triangle proportionality theorem. The triangle proportionality theorem states that if a line is parallel to a side of a triangle and intersects the other two sides, then it divides those sides proportionately. The converse of the triangle proportionality theorem says that if a line divides two sides of a triangle proportionately, then that line is parallel to the third side of the triangle. So we have to determine if these two pieces are in the same proportion. So that's what we're going to do right now. We can set up a proportion any way we want. We can use 10 to 20, 10 to 16, any way we like. So I like this 10 to 20 here. So for number 11, we're going to say 10 is to 20 as 16 is to 28. Well, this comes out to 1/2, and this comes out to 4/7. So this is not a true proportion, because if we cross multiply, 1 times 7 is 7, and 2 times 4 is 8. These are not equal. This is not a true proportion. So this segment is not parallel to CD. Let's try 12. We can do the same thing here. Let's just go this way. 12 to 20 is 13.5. 222.5. 12 to 20 simplifies to 3/5. And 13.5 divided by 22.5 is 3/5. So yes, these are in proportion. Therefore, these two triangles are similar, and this is parallel to CD. So let's move on to the next problem. In this problem, we are using the triangle proportionality theorem, and we can set up our proportion any way we'd like. We're looking for this segment, the length of YB. And so we can say this is to this as this is to this. We could have said this is to this as that is to that. That's the beauty of these problems. You can set up your proportion. It's almost visually set up for you. You can look at it this way and this way. You could look at it sideways, going that way, any way you'd like. Well, I like it simple, and I like my variable on the upper left. So x is to 24 as 7 is to 15. I could have said x is to 7 as 24 is to 15. Any one of those would work. X equals 24 times 7 divided by 15, which equals 11.2. So a pretty basic problem. Now let's go for the last two problems. In these two problems, we're asked to find the length of segment AB. In problem 14, it looks like we're using the three parallel lines theorem, which says if three parallel lines intersect two transversals, they divide the transversals proportionately. So here, just like in the last problem, we have a fairly visual setup for our proportion. We could say x is to 7 as 6 is to 4. We could say x is to 6 as 7 is to 4, any way we'd like. Problem 14, I'm going to set up x is to 7 as 6 is to 4. X equals 6 times 7 divided by 4, which is 10.5. Now for problem 15, we have to do something a little different. This is the triangle bisector theorem. You can see that DA is the bisector of angle A, and therefore that angle bisector divides this proportionately, where this is to this as this is to this. And we could set up a bunch of different proportions any way we'd like, but that's the basic one. So I'm going to say BA, because that's what I'm looking for, x is to 4 as 18 is to 10. X is equal to 18 times 4 divided by 10, which is 7.2. Now I could have done that another way. I could have said 4 is to x as 10 is to 18, 4 is to 10 as x is to 18. It really doesn't matter. 4 is to 10 as x is to 18. And again, you have 18 times 4 divided by 10. So either way you work these proportions, as long as you don't mess them up, you can't say x is to 10 as 4 is to 18. That will not work. So just look at them visually and you should be okay. I usually try to turn my head and look at it this way. So from here to here and from here to here. It's a little easier than looking upside down or something of that nature. In any case, that is the Chapter 8 review, and I hope it helped, and I hope to talk to you in the next video.